Um, Good morning, everyone. We are starting now with our class for the day. Uh, so today we are continuing with the proofs. So we are going to continue with the proofs. I've given you about 4 proofs on Euclidean geometry. So today I'm going to add. I'm going to add another important proof under Euclidean geometry. So, which is very popular as well. So, we'll be given a cycle like that, and then inside a cycle, we're going to have a shape of which this shape, uh, let's say we have A here, we have B here, we have C there, and we have D. So, A, B, C, D, it's a cyclic quad in this case. So we know from the information I gave you the last time that a cyclic quad, if you add angle A plus angle D on a cyclic quad, it must be equal to what? It must be equal to 108. I believe you know that. Is that so? I gave you that theorem. You still remember that theorem? Of the cyclic quad. You still remember the theorem of cyclic quad? All right. So we're going to prove this theorem of cyclic quad, wherein the addition of angle A, when you add it with angle D, they must be equal to 180. So now, in order to prove this theorem, in order to prove for the theorem of cyclic quad, Adish is here with us now. So Adish, we are going to prove a theorem of cyclic quad. So cyclic quad, when you add the opposite angle, it must be equal to 180. So now, in order to prove that A plus B is equal to 180, you need to create a center of the cycle. Every cycle have got a center. So let's say this is center O. And then on that center O, then we create a line that goes from the circumference at point C to the center of cycle O, and then another one which goes from the center and then to B like this. So where this is O. So if that is O, then it means we have O1 here and we have O2. I believe we are speaking together up to so far. So we have O1 and O2, and which are created from. Actually, let me have this as the dotted lines so that you can see that these are the lines we created. Solid lines will be presenting lines which are given, but the dotted lines, they represent lines which are given like that. So we want to prove that if we add A and D, they must be equal to 180. So in order to prove for that, we need to use the theorem we used the previous time, which says the angle at the center is twice the angle at the circumference. So of which in this case, it simply tells us that angle O2, it must be equal to 2 times angle A. Why? The angle at the center is equal to twice the angle at the circumference. I believe you still remember this theorem. Is that so? Are we together, all of us? Yes. So now we created this relationship between O2 and O and A using the theorem, which says angle at the center is twice the angle at the circumference. So it's the same thing we're going to use on O1 and D. So O1 in this case will be equal to 2 times D, like that. And it's the same reason that we're going to use in this case, that the angle at the center is twice the angle at the circumference. So you must not forget this information. After having that, we are going to take advantage of the cycle we have at the center. wherein we know that O1, when we add it with O2, it must be equal to 360. Why? Because this is the angle in revolution. So when you add O1 and O2, they must be equal to 360, like that. So after having that, where we have O1, we're going to substitute 2 times A, and where we have O2, we're going to substitute 2 times D. Let's substitute and see what we obtain. So we're going to get, where we have O1, we substitute 2A, plus where we have O2, we substitute 2D, and this must be equal to 360 degrees. So 2 can be factored out as the common factor. So it means we're going to have 2 into A plus D, which that will be equal to 360. Then you divide both sides by 2 so that this 2 here cancels with that 2. Therefore, we're going to have A plus D. It will be equal to 180 degrees. And you have proved what we wanted to get. We wanted to show that when you add two opposite angles in a cyclic quad, this must be equal to 180. And that is how you get to that proof that we have done. So now ask me any question before we go any further. Did you all understand that proof we have on the board?
No.
All right, I'll repeat for you. Let me also ask if beside Tondani, you understood the theorem. Did you understand the theorem?
Yes.
All right. Rochizwa, did you understand the theorem? Rochizwa, did you understand the theorem we have on the board? You can unmute your mic and talk. Did you understand that theorem we have on the board?
Yes.
All right. So for the sake of Tondani and Nikiwe, who joined now, let me explain the theorem again, because this theorem is very important. Nikiwe, how are you?
I'm good, thanks. How are you?
I'm also good. So I'm gonna explain this theorem again, just for you and Tondani, because you joined the meeting just now. So we're proving a theorem of a cyclic quad, wherein if we are given that A, B, C, D is a cyclic quad, that simply tells us that the sum of opposite angles are equal. So it means angle A, if we add it with angle D, it will be equal to 180 degrees. That is a theorem of which we want to prove just now. So in order to prove for that theorem, we have to create a center of the cycle, because any cycle you will come across in this world, it must be having a center. So we create a center O, so and then we construct a dotted line that joins at the center with circumference at point C, and again at the circumference at point D. So after constructing that line, then you will have angle O1 and angle O2. So now you have a quadrilateral with O1 and O2. So now, in order for us to prove for this theorem, we have to start with this theorem here. We are taking advantage of this theorem we did the last time, which says the angle at the center is twice the angle at the circumference. I believe you still remember that theorem, wherein if we add angle O2, angle O2, it must be equal to 2 times angle A. By using that theorem of angle at the center is twice the angle at the circumference. So that is what we have here. O2 will be equal to 2 times A. And same thing we do for O1. So O1 will be equal to angle D down there. So, and we're using the same theorem. Angle at the center is twice the angle at the circumference. Are we together with regard to how we constructed these two angles here, angle O2 and angle O1?
Yes.
All right, Tondani, are we together up to here where we constructed angle O2 and angle O1?
Yes.
All right, and then after having that, we then have to use another property wherein if we add angle O1 with angle O2, they must be equal to 360 degrees because these are the angles in a revolution. So this is what we have done here. Angle O1 plus angle O2 must be equal to 360 because these are the angles in a revolution. So after having that, then where we have O1, we can substitute what we obtained up here. So where we have O1, we substitute 2D, and where we have O2, we substitute 2A. So we're going to get what we have down there. Then from there, we factor out the 2. And when we factor out the 2, you will obtain that. And then you divide both sides by 2. 360 divided by 2 is 180. And that is what we wanted to get with regard to these questions. So angle A, when you add it with angle D, it must be equal to 180 degrees. Is that theorem clear to all of us?
Yes.
All right. Tondani and Maria, did you understand that theorem we have on the board?
Yes.
Yes.
All right, wonderful. So before we go to questions, I would like to give you another proof. So I would like to give you another proof before we go to the questions. Let me give you that proof just now. So this is the theorem I want to prove for you just now. Wherein we want to prove that angle O1 will be equal to angle O2. So angle O1 will be equal to angle O2 only if AB is equal to C. So let me put this line just to show that angle AB is equal to angle CD. With that information, we want to prove that angle O1 will be equal to angle O2. Are we together?
Yes.
All right. So let's prove that. Let's prove that. So now the first thing here is to observe that angle AO is equal to angle OB, which is equal to angle OC, and that is equal to angle OD. Can anyone tell me why all those four sides are equal? Why we say these four sides are equal? AO is equal to OB is equal to OC is equal to OD. Why? Why do you
They
think
are
those four
yes.
sides?
The radiuses of the same circle.
Those are the radiuses of the same cycle. Very true. So these are the radiuses of the same cycle. That's right. There isn't. These are the radiuses. So now, if these are the radiuses, so what does that mean? That simply tells us that so the opposite angle to OA is equal to the opposite side to the angle OB, which is angle B and angle A. So these two angles will be equal. So so in this case, we can say angle OAB equal to angle ABO. Why? Because AO is equal to OB, as simple as that. And we do the same on this other triangle here, that angle OCD will be equal to angle ODC. Why? These are equal because OC is equal to OD. And because these are equal, that will simply mean that this angle here will be equal to that angle, will be equal to that angle, and will be equal to that angle. So we have angle OAB, which is equal to angle OBO, which is equal to angle OCD, which is equal to angle ODC. So all these angles are equal. All of them are equal. All right. So if they are equal, we can then talk about this angle O1, which we want to prove. So let's prove that angle O1. So it means we can decide these other angles we have here. We're going to write them in terms of angles here. Why? Because they are equal. So we are no longer writing angle OCD and we're no longer writing angle ODC. All of them, we will write them in terms of these other angles here because they are equal according to this statement. So now let's continue. Then the next thing will be to prove to get this angle O1, and then from there we'll get angle O2. Let's start with getting angle O1. So now when we calculate for angle O1, this is what we're going to get. We're going to get angle AOB plus angle AOB, and then the second one is angle ABO, and then the last one is angle BA. And any one of you tell me, what will that angle be equal to? If we add this, and that angle, that will be equal to what? If we add these three angles here, they will be equal to what? They will be equal to 180 degrees. Why? Can you give me a reason why we say they will be equal to 180 degrees? Any idea? Why will those angles be equal to 180 degrees? These three angles here, this angle here, that angle there, and this angle, they will be equal to 180 degrees. Why will these three angles be equal to 180 degrees?
Sum of angles in a triangle.
Yes, those are the angles inside the triangle, as simple as that. And then from there, we make this angle O1 the subject of the formula. So which one is O1 here? Is this one. So that angle, we must make it the subject of the formula. So and it will give us AOB, which is equal to 180 degrees minus. Remember, these two angles, they are what? They are equal, right? So you can add them together and you then take them to the other side. So it means we're going to have 2, and then instead of having these different angles, you just write one of them. Let me write this one, ABO, like that. So we are now having angle O1, which is given in terms of that. And we do the same on the other side. And I tell you without any hesitation that it's going to give us exactly the same thing like what we have done here, because all the sides here are the same with the sizes we have on the other triangle. So it means the angle angle COD will be equal to 180 degrees minus 2ABO. So the right hand side of this will be equal in that case. And once the right hand side are equal, we can then conclude that angle AOB is equal to angle COD. And that is what we wanted to prove, that angle O1 is equal to angle O2. So it's another important theorem which you must all know. When you are given two sides which are equal here on these two triangles, then you must know that the angles at the center, they will be equal as one. So I believe we are clear on that theorem. So I've covered two important theorems today, and I believe we have covered the most important theorems under Euclidean geometry for grade 12. You must not forget even a single theorem because all of them are very important. So all these theorems, they are very important. This moment, let me give it to you to furnish me with the questions that you can do in the board. So it's your time to send me the questions that you think I must cover for you today. And at this moment, I think you can give me any question for Euclidean geometry, because I believe we have covered all the necessary proofs that are needed for you to know under Euclidean geometry. So give me any question, as long as that question is under Euclidean geometry, we must be able to attend to that question today. So the time now to give me the question. You are sending the questions. All right. I received a question from Adi. So it says in the diagram below, AOC is a diameter of the cycle. AP is a tangent to the cycle at A. And AE is equal to EP. So that is the information we are given. Then our task now is to prove that BA will be equal to OD. So we have to prove that BA will be equal to OB. That's the first one. And then the second is to prove that AOCD is a cyclic quadrilateral. AOCD is a cyclic quadrilateral. That's the second question. And the third is to prove that DC is a tangent to the cycle at C. DC is a tangent to the cycle at C. So that is the information we are given. So now let's quickly attend to the question just now. So we're given a cycle with a tangent which looks like this, and the triangle inside here is the center. Another line like this, and here. So here we have O, which have O1, O2, O3, and here we have A, where we have A1, A2, A3, and then here we have another line which goes like this, wherein it's D, where we have 1, 2, 3, and then is P. So we are given this information. And the E is E1 here, E2, E3, and E4. That is given. These two are equal. So it means this line are perpendicular. This line and that line are perpendicular. So let's try to answer the first question there, which talks about proving that BA it must be parallel to OD. So this line DA must be parallel to the line OD. So the question is, how are we going to prove this theorem? And this is how I want to prove this theorem. So to prove that the line AB is parallel to the line OD. So there's just one information which you must take into consideration, wherein the parallel lines, we know when you draw a line like this, it must form a what? A 90 degree. All the time, it must form a 90 degree. So the first thing we can do in this case is to show that this angle A here, it is equal to 90 degree. We must show that this angle A, it must be equal to 90 degree. Let's say, in this case, we can say angle A2 plus angle A3, they must be equal to 90 degree in order to show that these two lines are parallel to each other. Because already we know down here we are given, if we are told that this line and that line, I mean AE is equal to A, what is this line? I think it's C. If these two lines are equal, what does it say about this line and that line? So it means these two lines are what? Are perpendicular to each other, right? It's an information which is given from the first theorem I proved for you. So angle E1 will be equal to angle E2, which is equal to 90 degrees. Why that is equal to 90 degrees? So we are using the what? The midpoint theorem, right? Are we together? Are we together?
Yes.
Yes. That information is given that angle E1 or E2 is equal to 90 degrees because of the midpoint theorem. And then how can we justify that E2, in this case is A2 plus A3 is equal to 90 degrees? Can you give me the theorem which can justify that? How can we say A2 plus A3 is equal to 90 degrees? Which theorem can we use to justify that?
Angle that is subtended by a diameter.
This is a diameter. Therefore, if it is a diameter, it means it's going to form a 90 degree up there. So we have angle subtended by a diameter. Once we have a 90 degree, that simply tells us that the conclusion, we can now conclude that AB is parallel to what? To OD, and that's all. We can conclude once we get the 90 degrees here and the 90 degrees down there. Therefore, we can conclude that the two sides are parallel to each other. Are we clear? Are we all clear with regard to the first question I proved there? Do we have any? Okay, let me find those who say they understand the theorem. Who understood that theorem? The first question. Who did not understand the first question?
Nikiwe.
Or Nikiwe?
Ruchizwa.
Okay. So Ruchizwa and Nikiwe, you did not understand the first question, right?
Yeah.
All right. Let me explain it again. So in this case, we want to show that line AB is parallel to line OD. And I said, in order for us to prove that the two lines are parallel to each other, so we must show that if we draw a line that goes like this, of which in this case is the line AC. So if we draw line AC, it must form a 90 degree here and a 90 degree there. So if we have a 90 degree here and a 90 degree there, it simply tells us that these two lines are what? Are parallel to each other. Are we together? Yes. So in this case, it means we must show that angle E1 is equal to angle A2 plus A3. Are we together?
Yes.
Yes. So in this case, from the information we are given, A1 and A2, A1 equal to A2 is equal to 90 degree. How do we know that it's equal to 90 degree? Because we are given a midpoint theorem. A midpoint theorem, it comes from this fact that AE is equal to EC. So if AE is equal to EC, therefore that means these lines which goes from the center to that line is cutting exactly at the midpoint. So, and once it's cutting at the midpoint, therefore angle A in this case is E1, which is equal to E2. They must be equal to 90 degrees. Do we all understand the first theorem? All right. And now the second theorem, already we know now that we have a 90 degree there, according to the first theorem. So the next mission now is to prove that even that is going to give us the what? The 90 degree. So in order for us to obtain that even here we have a 90 degree, so we must take advantage of the information from the diameter, because the diameter, when it subtends here at the second side,
Oh.
forms a 90 degree, right? So now A2 plus A3 will be equal to 90 degree because that angle is subtended by the diameter. So that's why we say it's an angle subtended by the diameter. So it means we have a 90 degree. Is that clear?
Mm.
And once we have 90 degrees here, so it achieves this property we have here. So once we have 90 degrees up here and the 90 degree down there, so it means these two lines are parallel to each other. Do we have any question before we move forward?
Reason yone e ḓo vha ifhio?
Okay, reason for AB to be parallel to OD is because A2 plus A3 is equal to A to E1, like that, which is equal to 90 degrees. So that is the reason.
So it ḓo vha a corresponding angle.
Yeah, exactly.
No. Oh yeah.
It's in this case, it's gonna be the co-interior. When you add the two co, it's 180 degrees.
Oh, okay.
Yes, yes. All right, we can go to the second question, right? The second question is talking about a cyclic quadrilateral. We want to show or to prove that AOCD is a cyclic quadrilateral. So here, we want to show that this is a cyclic quadrilateral. So the question is, how are you going to show that this is a cyclic quadrilateral? I can simply tell you in this case that we can show that this is cyclic quadrilateral by showing that this angle here is equal to the angle we have up here. I believe you still remember this theorem, wherein if we are given, we want to show that this is a cyclic quadrilateral, we need to prove that this angle down here is equal to the angle we have up there. So now it means here we are going to show that angle D1 is equal to angle O1 plus angle O2. Are we together? We want to show that angle D1 is equal to angle O1 plus angle O2. I hope we're together on that one. Is that so?
Mm-hmm.
Yes.
Yes, yes. So we want to show angle D1 is equal to angle O1 plus angle O2. So now, before I chip in, I would like to find out from you. So how do you think we can approach this question? Which theorem can we use in order to show that angle O1 plus angle O2 is equal to angle D1? How do we show